So when we talk about starting radicals, we're going to first just focus on square roots. But to define this first, let's say I have something like this. How we read this is that this is the nth root of a. Nth root of a. So n is the root, a is the base. The whole thing is a radical. So that's what we're doing here. We're doing radicals. I'm going to rewrite this. The nth root of a to the nth. So what this is kind of saying is that roots are the opposite of exponents. So this would just simplify to a. So let me start throwing up the first example. So if we were doing the square root of 9, if there's nothing there, we assume it's like, oh, not a 3, a 2. Square root. If there's nothing there, it's a square root. So if we were to rewrite 9 as 3 squared, that's the same thing. We just get 3. So we're looking at, if we have 9 here, what times itself gets us 9? It's 3. So our answer is 3. So one thing we need to watch for, and I'll put up an example of this, is that if n is even, then what this equals is the absolute value of a. And let me kind of show you, and we don't often come across this, but just to show you how this should kind of make sense, is if we have the square root of, in parentheses, -5 squared. So if we kind of just look at this definition right here and think, well, the square root and the square are going to cancel, we would get -5. But that's not going to be correct. Because if we kind of work this out right here, -5 squared, -5 times -5 is 25. The square root of 25 is 5, not -5. So that's where if we had taken the absolute value of -5, now we get our correct answer of 5. So that's why if you see this in a book, why we see that absolute value. Okay, so we talked about square root of 9 is 3. How about, let's throw in an x. So how about the square root of x squared? Okay, so this is saying what times itself gets us x squared. Well, it would be x. X times x is x squared. And technically, like we just talked about, this would be the absolute value of x, but how we're in reality, we're going to mostly just put x. How about, let's go back to a number. Now we'll get a little trickier. How about the square root of 50? So nothing times itself nicely gets us 50. I mean, we could punch this in our calculator and we'd get somewhere around 7.0 something, because since square root of 49 would be 7. But how we're going to simplify, as we get into higher math, we want to pull out anything we can. We want to pull out anything that we can do the square root of. So we're going to break this down. We're going to break down 50 into a perfect square, which 25 goes into 50 times 2. Okay, so these numbers we're looking for in here would just be, let's make a little chart over the side. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared 25. Okay, we'll keep on going if we need to. But we're looking for any of these numbers that are in 50. When I'm saying in 50 multiplied by another number. So now, since right here, what we can do is we can break this apart. This is the same as square root of 25 times square root of 2. So now I can simplify square root of 25 is 5. I can't do the square root of 2, so that just comes down. So 5 square root of 2 is square root of 50 simplified. Let's do that same idea with x's. And we just did square root of x squared is x. How about the square root of x cubed? So just kind of like we did with the numbers, let's break this down into something we can simplify. So if I break this down to x squared times x, that's the same thing, right? X squared times x is x cubed. I can do the square root of x squared. Let's rewrite this as, break it apart. Square root of x squared is x. I can't do square root of x, so that just comes down. Okay. Let me kind of show another way I might kind of rewrite this. You know, maybe just underneath I'm going to write a little x squared next. This one right here, this can come out as an x. This one has to stay inside. So maybe with the next example I'll kind of write it out like that. I'll keep my little chart of numbers up for now. Okay, how about the square root of 18 x to the 7th y to the 10th? Okay, so we've got a lot going on right here. So now I'm combining some numbers with variables. So we'll kind of just break it down. I'm going to write out a bunch of different parts to this. So let's first just look at the number. So remember, we're looking for just these numbers. All I care about are perfect squares because these are going to be where I can actually do the square root of them and a number comes out. So 18 breaks down to 9 times 2. So the 9, this is going to come out as a 3. Square root of 9 is 3, and then that's not going to be in there anymore. 2 is going to have to stay inside. X to the 7th. Okay, so now I'm going to break this apart into a bunch of x squareds. X squared, x squared, x squared, and x. 2, 4, 6, 7 of them. So each one of these that comes out, that's going to be an x. X comes out as an x. All those came out. This x is going to have to stay. So let's see what we have so far. So far we have 3 on the outside, x cubed on the outside, x times x times x. I'll leave a little room if I'm going to have a y. So far on the inside I got a 2 and an x. Okay, so last I'll do the y's. Y to the 10th. So how many y squareds is this going to break down to? Y squared, there's 4, 6, 8, 10. Okay, so each one of these y squareds is going to come out as a y. Okay, 1, 2, 3, 4, 5 of them are going to come out. So y to the 5th is going to come out. All of these come out, nothing's left inside. So kind of notice though, let's go back to the x and the y. X is odd. There's going to be one left over because every paired up one is going to come out. If your exponent is even, they're all going to come out because they're all going to be paired up with something. So notice too what kind of happens, the trick with this. And you know, as you do more of these, hopefully you don't have to write this out so detailed. You can come up with a little quicker. It's basically we're just dividing by 2. What's 7 divided by 2? 3.5. So that means 3 full ones came out, 1 was left over. So that half represents that there's still an x in the square root. 10 divided by 2, 5. Came out evenly, so that means there's 5 on the outside. Okay. Okay, let's do one more. How about 3 square root of 32? X to the 5th. So one thing I put in a little different here, there's already a number in front. But just keep in mind, this is all multiplied together. This means 3 times all of that. Okay, so when I'm going to break down 32. So I'm kind of looking here. Oh, 4 goes into 32. 4 times 8 is 32. So, but then I'm kind of thinking ahead. Well, 8 also has a 4 in it. So let's kind of keep going down if we can. 16. 32 breaks down to 16 times 2. Okay. X to the 5th. I'm going to break this down just to x to the 4th times x this time. I mean, I could break this down to x squared, x, but let's try to think ahead a little and think x to the 4th. This is going to come out as x squared. And then the 16 is going to come out as a 4. Square root of 16 is 4. So now, I've already got the 3 there. Now I'm putting a 4 out there. This is multiplied. So now it's going to be 12. X squared, square root of, so let's see, that came out. 2 has to stay in, x has to stay in. So 12x squared, square root of 2x.